All right, and welcome to the first set of notes for Algebra 1b. Here we go with just reviewing types of functions. So not always do we use the same type of function. Sometimes we'll use a linear, sometimes it'll be quadratic, sometimes it'll be exponential. So here's a real quick review of those three. So the first one, the one you're probably most used to, is the linear function. Now remember, this has the word line right in it, so it's a dead giveaway that it's a straight continuous line. Okay, so pretty simple here, and you're probably used to this equation, the one that you could think of the easiest. Y equals mx plus b. Okay, so we're used to seeing the y and the x because that makes up the y and the x axes, right? So that's always going to be in our equations, but the other letters will sometimes change. So in this case, the m is the slope, and the b is the y-intercept. Now remember, that's where the line will cross the y-axis. So its name gives a lot of the information that we may have. Let's come up with a simple example like y equals negative 1/2 x plus 4. So the slope of this is here, the negative 1/2. So it's going to rise 1 and run 2. And then it's going to cross at the 4 on the y-axis. So let's go ahead and graph this over here on our sketch where we put a 4, a point where 4 would possibly be obviously above 0 on the y-axis. And since it's negative, it would be going down as it goes to the right. Now we didn't have boxes to count down 1, right 2, but we just can make a sketch of a line that looks like it's going down, continuous and straight. Okay? Questions on that, please let me know. For the next page, we're going to talk about our quadratic. So sounds fancy, but you see the U in the quadratic? That's a little hint that this is a U-shaped graph. Okay? And we would write this out as y equals ax squared plus bx plus c. So we have a little bit more to this one. We still have our y and we still have our x, and we have two of them. And the key to this is the highest exponent in these will be x to the second power. We need to have that in order for this to be a quadratic, because if we just have x to the first power, then it's linear. C, in this case, is the y-intercept. So just like we saw with the linear, that's where it's going to tell us where it crosses the y-axis. You know, and these could take a couple of different forms, but I'm just going to make one up where y equals 2x to the second power plus 4x minus 5. Now these numbers here, they're called coefficients, could change. All right, those could be different. Just understand that sometimes those will change, but the variable x squared must be in the problem. I'm going to draw a quick sketch of a y and x axis and do two of them. And the reason is we have two different types of quadratics. All right, the example here has a -5 for the y-intercept. So I went below 0 and drew or put a point. And now I'm going to draw in the U-shaped graph. Now this one is upward, and this is when the x squared has a positive in front of it. Okay, and that's key. Now this one I'm going to draw out would be a negative, so that one's facing down, and this would be a negative x squared because of that. Okay, if you have any questions on that, please let me know. Moving on to the next one, which is exponential. All right, there are unfortunately no tricks to the name of this one, but it is simply a rapidly increasing or decreasing graph. Okay, and we'll take a look at that, what that looks like in a second. But first, let's get to the equation. The equation is y equals, there's our y again, a times b, But where's the x? I said that there's always going to be an x here. Well, now it's an exponent, all right? So the key to this one is it has the word exponent right in it, and that is what the variable x is. Now, I know we'll keep changing this up, but this time the a is the y-intercept. It would be kind of nice if they were all the same letter, right? B is the multiplying factor. So that's how much it's going to increase or decrease. I'm going to explain that in a second. So anytime the b value is greater than 1, all right, bigger than 1, it will increase. And let me show what I mean by that by drawing a quick little sketch over here. So I'm going to go a little smaller because I'm going to do 2. And so the graph of this one would start really low. It would never go below the x-axis, and then it would rapidly increase to finish if it was an increaser. Okay? Now, we can't have a negative multiplying factor because that would totally change things up for what we're trying to do in this class. We're going to keep it positive, but we're going to keep it between 0 and 1. So when I write that, that should look familiar. This is greater than 0, but less than 1. So between 0 and 1, and this will cause it to decrease. And what do I mean by that? Well, if I drew a quick sketch of it, that's a pretty bad graph, but that's okay. It's going to start near the y-axis, not go over it, go down quickly, and then slowly kind of level out. So it's a rapid decrease to a slow decrease. And these ones, if I was to kind of make one up, would typically look something like y equals 3 times 2, because we're multiplying, to the x power. Now let's not forget that this one right here is the y-intercept. And again, if that's 0, that's a little bit above 0. Okay? If you have any questions about that, please let me know. Moving on to some scenarios. Let's see if we can identify these as linear, exponential, or quadratic. Now remember, linear stays constant. It's always the same. Exponential will see a rapid increase, and then quadratic will kind of see it double back on itself. So it'll start at one point and then eventually get back to it. So the first one is Ian is saving up to buy a new baseball glove. Every month he puts $10 into a jar. Okay, so every month it's the same. It's $10, it's 10 more dollars, it's 10 more dollars. That is a classic linear. So we're going to go L for linear. Next one, a gym charges a membership fee of $10 down and $10 a month. Well, this is simply just our starting cost. So that's kind of like a y-intercept. That's going to give us a little bit of a head start. It's still doing the same thing as the first one. $10 a month, $10 a month, $10 a month. So that is a linear. Now, an employee's wage that increases 2% every year will increase at a different amount. I know that 2% sounds like the same, but if you do 2% of 100 and then do 2% of the next number, it's going to be more each and every single year. So this is growing faster. So there's our exponential. All right. Typically, anytime you see a percent, it's going to be an exponential function. A cab company that charges $2.50 initially and $3 per mile. We've kind of seen this already, right? An initial value starting us off with something and then the same amount every mile. So that is back to linear because it's $3 every mile. A car at $12,000 that depreciates 15% per year. They'll always say it, car is your worst investment, right? Because you'll never get the money you'll get out of it that you put into it, what you paid for it. So this is rapidly decreasing. It's a percentage, so it's an exponential function. All right. Next up, a vine that grows 6 inches per week. I want you to think about this. What do you think it is? Linear, exponential, or quadratic? Well, since it's every week the same amount, it is linear because it's constant. But a species of flies that doubles its population every month sounds constant, but think about it. Let's say it started with 4, and then it doubles to 8, and then it doubles to 16, and then it doubles to 32. Oops, 2. That's not increasing by the same amount, because if we were to look at this, it went up 4, it went up 8, it went up 16. These numbers aren't the same. It's actually an exponential because it's doubling every time. And the last one, the height of a ball can be represented by an equation, which is represented by negative 8t to the second plus 40t plus 5. This is the key. We talked about it in the notes. The highest exponent being 2 makes it a quadratic. Okay? Nice job. We have one more slide to go. And the last slide is looking at these from a table. So when we look at these from a table, we want to see how much the y value or output is changing. So this one changed by 3, changed by 3, went up by 3. Okay? So that added 3 every time, so that makes it a linear function. It's constant. This one went up by 1, went up by 2, and went up by 4. So that's not the same when we tried to add, do what we just did. So let's think about something else. Instead of adding, what if we multiplied? And we multiplied by 2. 1 times 2 makes 2. And then if we did 2 times 2, it would be 4. And then if we did 4 times 2, it would be 8. So since we are multiplying, this is a exponential. So let's put the exponent there and then add in the IAL. All right. Last one. If I tried to look at this, it would be plus 3, plus 1, plus 1, plus 3. So it's clearly not linear. And let's watch how these match. 4 to 4, 1 to 1, and there's kind of like a turning point, a TP right here. This is your classic quadratic example. Okay, so hopefully these look familiar from last year. I did kind of lie to you. I said that was the last slide. There is one more, but it's a quick one. Okay, and that's just determining these from a graph. So if we were to quickly look at these three, which is which? Which one's linear, which one's quadratic, and which one's exponential? Hopefully you'll be able to tell from our notes earlier, but here we have a straight line, right? And this would be a linear function. Here we have our U shape that is upward. So this is a quadratic. And lastly, we have our slow riser to our rapid increase. And so that would be our exponent, our exponential function. Okay, just want to do a quick recap of the 3 types of functions you'll be seeing the most this year. And let me know if you have any questions.